Et bien, on a commencé. Mais bonjour à tous. Donc, bienvenue pour cette 6e session des Zooms de la SFGP organisée par le groupe thématique Ingénierie avancée des procédés. Alors, ce Zoom a vocation à faire le lien entre l'intelligence artificielle et les jeux des procédés. Et aujourd'hui, le webinaire que nous allons présenter aura une attention particulière à l'utilisation de l'IA dans l'industrie. Alors, avant de rentrer dans le vif du sujet, je voulais simplement remercier donc, la SFGP pour accueillir ces Zooms. Martine Poux, qui est une aide véritable précieuse d'un point de vue technique et organisationnel, donc dans le bien déroulé de ces webinaires. J'en profite aussi pour remercier donc, Ludovic Montastruc, qui est co-organisateur de ces webinaires sur le GT-IAP. Et bien entendu, je finirai par l'ensemble des membres du groupe de travail IAP pour leur bonne humeur et leurs conseils avisés. Alors, comme je disais, nous sommes à la sixième session de ces webinaires. Et juste pour un récap, nous avons commencé la première session le 28 janvier 2021 avec une approche, avec un overview des liens entre l'intelligence artificielle et le génie des procédés. Et nous avons terminé avec une petite faute, le 24 mars 2022, le cinquième webinaire avec une attention sur l'utilisation de l'IA dans les molécules et dans la génération de procédés. Alors, je tiens simplement à rappeler que tous ces webinaires sont encore visibles via la chaîne YouTube de la SFGP. Alors, aujourd'hui, nous allons suivre le programme suivant. Donc, après un mot d'introduction de François Nicol, président de la SFGP, nous entendrons 2 présentations réalisées par des industriels. Et le premier s'attachera à montrer l'intérêt de l'intelligence artificielle dans le monde de l'industrie. Et cette présentation sera principalement dirigée par Guillaume Serin de Sanofi et par Federico Scattolin de la société du Stevanato Group. Et nous finirons par une présentation de Pierre-Louis Bescond de la société Roquette, qui s'attachera à nous montrer l'intérêt des approches deep learning dans le process monitoring de façon plus générale. Alors, juste avant de donner la main à François Nicol, je tiens simplement à vous dire qu'après chaque présentation, vous aurez la possibilité de poser vos questions et on vous répondra en direct, donc via l'option Q&A posée par Zoom. Donc, n'hésitez pas à aller à cliquer sur le bouton, à poser vos questions. On les citera oralement et puis l'intervenant pourra répondre. Donc, avant de passer aux questions, donc je donne la main à François Nicol qui va nous présenter, qui va faire 2-3 mots sur la SFGP. François.
Merci Roda et bonjour à toutes et à tous. Donc en effet, c'est avec grand plaisir que je vais ouvrir cette session des Zooms de la SFGP. Donc c'est une session qui vous est offerte par notre association. Donc la SFGP, c'est ce qu'on appelle une société savante dont l'objectif est de promouvoir le génie des procédés. Et je pense que l'un des points forts de la SFGP, c'est qu'elle rassemble à la fois les universitaires, donc les chercheurs, les académiques, et les industriels. Donc, on a un tour de table très riche d'industriels. Et je dirais que le moteur de la SFGP, ce sont ces groupes thématiques. Donc, aujourd'hui, cette session est organisée par le GT Ingénierie avancée des procédés, qui s'est montré en effet particulièrement actif pour organiser ces Zooms de la SFGP. Donc la SFGP, c'est aussi une petite équipe dynamique au niveau corporate. Donc, autour de moi, Martine Poux, qui est la déléguée générale de la SFGP. Nous avons également un vice-président académique avec Nicolas Roche, d'Aix-Marseille, un vice-président industriel qui est aujourd'hui représenté par Pierre Kiner de Michelin. Bien sûr, nous avons un trésorier, Patrice Méheux, et une secrétaire générale, Catherine Bonazzi, d'AgroParisTech. Donc, comme je disais, la SFGP, elle est riche de ses adhérents et on a voulu s'organiser en grandes régions de façon justement à se tourner le plus près possible des acteurs des procédés, à la fois les laboratoires et les industriels. Et donc, je fais le lien avec l'événement majeur de la SFGP qui est son congrès, qui a lieu tous les 2 ans. Donc, le message que je veux faire passer aujourd'hui, c'est évidemment rendez-vous et physiquement, parce qu'après cette longue crise sanitaire, c'est notre premier grand congrès physique qui aura lieu à Toulouse. Donc, ce congrès est organisé par la région Sud-Ouest et porté par les 2 laboratoires Toulouse et Montpellier. Donc, rendez-vous à notre congrès de la SFGP entre le 6 et le 9 novembre prochain. Et je voulais aussi insister sur le fait qu'à la SFGP, donc c'est un réseau, c'est un congrès, c'est de l'innovation en génie des procédés, et c'est aussi un lieu de production. Donc, certes, nous sommes tous des bénévoles qui voulons promouvoir le génie des procédés, mais on a également certains livrables, donc on s'organise vraiment en lieu de production. Donc, si vous allez sur le site web de la SFGP, vous trouverez un premier livre blanc qui a fait le bilan des forces du génie des procédés en France. Ensuite, on a voulu se tourner vers les jeunes, attirer les talents. D'ailleurs, j'en profite pour glisser que l'adhésion pour les doctorants, pour les jeunes diplômés est gratuite à la SFGP pour la première année. Et nous avons créé notamment le prix de thèse SFGP tous les ans, qui sera remis lors du congrès. Vous trouvez également sur le site un livre blanc sur l'usine du futur. Donc, je pense que là, c'est bien en lien avec la thématique d'aujourd'hui. Et aujourd'hui, nous travaillons à un nouveau livre blanc, donc une vision que nous développons autour de l'ingénierie du futur. Donc, pour conclure, je dirais que je pense sincèrement qu'il y a un momentum pour le génie du procédé aujourd'hui. On le verra au congrès avec les grands enjeux qui sont mis en avant, les enjeux sur l'eau, sur l'énergie, bien sûr, sur l'économie circulaire, ce qu'on a appelé ingénierie circulaire, et évidemment sur la réindustrialisation, ce qu'on a pu appeler industrie 4.0. Et là, donc, je fais le lien directement avec l'ingénierie avancée des procédés, le numérique et l'intelligence artificielle qui va vous être présentée aujourd'hui avec un focus, en effet, comme l'a dit Roda, sur l'industrie. Mais comme je suis trop bavard, je vais arrêter là. Donc, bienvenue encore à la SFGP. Et Roda, je te repasse la main pour la suite. Merci à tous.
Parfait. Merci François pour ces mots d'introduction. Alors, je vais donner la main à Guillaume, Serin et Federico Scattolin, s'il est présent, parce que je ne le vois pas sur le... Federico, where are you?
Federico, il faut brancher ton micro, il est coupé.
Can you hear me now?
Voilà.
Ah, yes.
Yes, perfect.
Sorry.
Voilà, je vais arrêter le partage et Federico, it's your turn.
Okay. Can you? Okay, very good. I will share the presentation. Here we are.
Okay, thank you, Federico. Can you hear me well?
Yes.
Yes.
So hello to everyone. I'm Guillaume Serin. I'm working in Sanofi, in the engineering vaccines, and I'm in charge of the engineering technical support. Today we are going to explain to you what we are doing with the Stevanato group regarding use of intelligence artificial and especially the deep learning for inspection machine. Just before, I just would like to show you what is the scope of what we are talking about. Sanofi, as you know, is a laboratory for medicine, and it has a vaccine part, which is Sanofi vaccines. And in this vaccine part, we are producing nearly 800 million doses of vaccines per year. We are world leader for flu vaccine and for polio vaccine. Industrially speaking, we have 12 manufacturing sites in 8 countries. We have also industrial partnership with CMOs, more than 40. We are still investing a lot to deploy new vaccines and to build industrial capacities that represent an investment for the last years of 1.2 billion euros. Also, within the global vaccine business unit, the industrial affairs represent 60% of the employees, and we have more than 40 nationalities. And we are handling in our industrial sites, let's say 21 virus with 6 different technological platforms. Next slide, please. So we have started to develop the use of artificial intelligence in our industry, mainly through our journey to transform our sites into 4.0 sites. We started this effort in 2019, and we have an ambitious plan until 2026. And today, what we are going to show to you is what we are putting in place in order to use the deep learning for the inspection of the syringe. This is done to simplify the processes, also to increase the throughput, but also to empower the shop floor and to capture value. If we go to the next slide, what we call inspection is, here you can see on the middle, it's a pre-filled syringe of vaccine, what you may use when you are vaccinated. And these syringes are filled in our, the liquid is done and filled in our factories and also inspected. Through the inspection, we want to detect any defaults, very small defaults, that could prevent the use of our products. And for that, we have a partnership with the Stevanato group in order to use what we call the inspection machine. These machines are very complex. They can inspect 600 syringes per minute, and all our syringes are inspected. So it represents hundreds of millions of syringes. And for these high volumes and this speed, we are fostering the use of artificial intelligence in order to improve the detection rate of the equipment and also to reduce the false rejects that we have, and to be better in the identification and the separation of real defects and false defects. That was my introduction. Now I'm going to leave the floor to Marco Costa and Federico Scattolin for the Stevanato group. Thank you.
Merci. Thank you, Guillaume. Hello, everybody. Marco Costa. I'm here in the role of main referent for Sanofi within a Stevanato Group organization. I will do a very brief introduction about Stevanato Group to all attendees, and then I will leave the floor to my colleague Federico for the more interesting part on the artificial intelligence. So Stevanato Group is a global player, is with an headquarter in Italy, but with a presence all over the world. We are close to our pharma partners in producing, as Guillaume anticipated you, systems to inspect the glass container after the filling process. But also we have a partnership with the pharma industry on the glass primary packaging. So we also supply, for example, the syringe, which Guillaume showed you on the previous slide. We are today we have an important position on different glass containers, on syringes, of course, but also on vials and cartridges. On the right part of this slide, you see some figures that are related to our engineering division. That is the core of our discussion today. We can go maybe to the next. Starting from this slide, I will ask Federico to take the lead and enter a little bit more in detail on this artificial intelligence concept with some example, also some real example in the end. We think it's there is a very big moment today in the market. Sanofi is, of course, always a pioneer in new technology, and this is why there is this interest and this collaboration between us. So, Federico, please.
Yes, thank you for the introduction. I also introduce myself. I'm Federico Scattolin. I work in Stevanato Group, and I am basically the system owner IE and the responsible of the AI team. Okay, today I prepare a presentation that include a quick introduction to what is artificial intelligence, basically, and then some use cases that we analyzed here in Stevanato. Let me start first clarifying what it is, an automatic vision system. As Guillaume said, we are using a machine that uses cameras and LED lights to inspect 100% of the production of different products, in this case syringes, and the goal, of course, is to detect good and bad product. A vision inspection system is based exactly on cameras, so it looks at images basically, and these images are processed with the use of a computer and of an inspection software. The inspection software normally use traditional computer vision algorithm, but today we are here to see what artificial intelligence method can do to improve this process. Okay, now I will show you a quick presentation, a quick video of what artificial intelligence is. After the video, we will go through the different points. Okay, so let's see the key points of this presentation. So what is artificial intelligence? First of all, it is the ability of a machine to solve problems and tasks that are normally performed by human operators, and it is based on neural networks, mainly on neural networks. A neural networks is a mathematical model in the end that try to reproduce the functioning of a human brain, of biological neurons, and to bring some reasoning within the process, the elaboration process. Okay, as I said, the neural network try to mimic the biological brain, let's say. So it is a network, a set of artificial neuron. Each neuron is a mathematical function in the end that has some weights, so some variables, okay? And it is connected to all the other neurons. The fact that all these neurons are connected together gives a lot of power, let's say, of intelligence to the network. These networks are implemented in different programming languages and run on a computer, server, or similar architecture, because sometimes we can find neural network also within microcontroller or even smaller devices. Okay. The neural network or the use of a neural network is divided into two phases. A first phase that is the learning phase or the training phase, and the use phase, the phase where you use the trained network. The neural network learn by example, so it learn how to perform a job by looking at some example. In the image on the right, you see we feed the network with cats and dogs, images of cats and dogs, and in the end, the network learn how to distinguish one set from the other. This is performed during the learning phase. So in the learning phase, we show to the network different images, in our case, because we work with images. We show images with a label or the indication of where to find the defects, so where the defects really is. And the network start to learn to distinguish them. This is a phase that normally requires a lot of time and computing power. So this is a phase that is performed offline, let's say, not during production. The use phase instead is the phase when you have a trained neural network and you want to use it for the production. So you freeze the model in the sense that it is no more possible to change it or to further improve it, and you put it you install it into a computer within the machine, and you can use the trained network to decide if a product is good or is bad. This is the flow that I just described. So we acquire the images with the machine during production or before production using some development kit, and offline we process the images. So we attach a label, good, bad, and similar, or we mark the defects on the images. Okay. We upload them in the cloud, and we create, we develop and train a neural network. At this point, the trained model is frozen and can be used in production. So we have two phases: the learning phase that is out of line and takes some time, and the use phase that is in line and is very quick. Now it must be very quick because at 600 pieces per minute, we do not have much time to perform the inference. How does the training work? Here I prepare a very quick slide to show you what is behind a neural network. We said that each neuron is basically a function, a mathematical function with some numbers, some variables. This number initially are random. Okay, so when you have a clean neural network, all these weights are initialized randomly. At this point, we start to feed the network, so the neuron, with some images with their label or with the position and label of the images. I will try to explain it better later. And we feed it to the network. The network will guess if it is good or bad. If the result match, so here we give a bad, the network state that it is good. Okay, in this case, we go back to the network, to the ways of the network, and we penalize the neurons that stated that the piece was good, so that gave the wrong prediction. By contrary, if the prediction is correct, we reinforce the neurons that gave that prediction. And this is how basically feeding a lot of images, the network start to learn how to distinguish, in this case, good from bad, but we can also distinguish crack, cheap, crack, and so on. So we repeat this process using several images, and we show the same images several times to the network. In the meanwhile, the network starts to increase its accuracy. And when the accuracy is not increasing anymore, as you can see in the middle graph, when we reach a stable condition where we do not increase anymore the accuracy, we can stop the training and say that the network has reached its final performances. There are other things that we can do if something is not working, but normally if something is not good, we need to go back to the data, and we will see why in a while. Okay, let me introduce now very quickly the two most common type of neural network. The most famous one, if you want, the classification network and the object detection network. The classification network is a network that associates a single or multiple label to an image. So one image, one label, or multiple labels, but we are not interested here in saying where the defect is. We are just interested in stating if the image is good or bad, if it has a crack, a break, a chip, or a scratch, and so on. So this is maybe the easiest type of network. In the object detection network, instead, we want not only to state if the image is good or bad, but we want to see if there is a defect, where it is, and even find associate a label to the defect. So in this case, in the images that you see, for instance, the network recognized the position, so the number and the position of the defects, and give me just 1 second, sorry, and also the type of defects that we have. Okay. Okay. Now, I prepared a couple of slides just to show you how traditional algorithms work and how artificial intelligence algorithms work and what is the main difference. So in a traditional algorithm, the intelligence, if you want, comes from a computer vision expert. The computer vision expert make the program, decide what features, so the main characteristics that are relevant to solve the problem. So in the example here below, for instance, you can see that we have an input image. We decide where we want to focus the region of interest. We decide how to extract the information that we need, the threshold that we need to apply, what we want to do. And then we select also what is important for us. So the length of the defects, the width of the defects, the area, and so on. And then we state some acceptance criteria that decide if it is good, the product is good or bad. With the AI algorithms, the main difference is that we do not program what is how to extract the information that we need. Basically, training the network, feeding the network with the images and the examples, the network decide by itself what is important and what is not important to solve the problem. And this is really interesting because there are things that sometimes the human being cannot appreciate, but a computer is able to see. So we are basically applying I'm going to say a statistical method to the feature extractor, to the feature extraction. Okay, so here we see in a very simple image the difference between traditional and AI algorithms. On a traditional algorithm, we supply the program, so we have to design the program, develop the program. We check the data. The operator check the data, feed the program, and check that everything is fine until we get the results. For AI products, instead, we give to the network both the data and the expected results, and in the end we get basically the program, so the trained network. So on one side, we need a computer vision expert that put the intelligence in the system, in the program. On the other side, it is the neural network itself that find the right program looking at the data. On a traditional algorithm side, we need few images, but mainly because we do not have time to look at thousands of images, okay, and to check thousands of images, because this is carried on by a human operator. On the other side, we need more images because the network learn with looking at the images, and the more images we give to the network, the more robust and stable is the final product. And the traditional algorithm select in the traditional algorithm, the features, the important features are selected by the computer vision expert, so contour, dimension, shape, color. On the other side, the network statistically determine what parameters are really useful. Okay, Now, let me show you some example of how we applied AI here in Stevanato Group. They are just some example, but we are working on several different machines, product, and kind of problem, let's say. So let me start with this one that is probably the first problem we analyze with artificial intelligence, and there is a reason because of this, and the reason is that this is a very complex problem, and it is very difficult to solve it with standard computer vision algorithm. In this case, we applied a convolutional neural network, a classifier, basically, to classify if the plastic ring of the saline drip was good or not. If you look at the images, these are some samples from the production, taken from the production. We have some good and bad samples, and they are both interesting because if you look at the bad samples, you will see that, okay, to a human eye, it's sometimes easy to understand that there is a problem here. In the first example of the bed, we have we miss a part of the ring. In the second, the ring is compressed at the form, and in the third, the ring is missing, totally missing. But if you look at the images with the standard algorithm, computer vision algorithm, it's very difficult to extract the features that we need to do a good job. Also, if we look at the good images, there are some noises. You see, the image is not always, it does not have always the same gray value. So there are images that are darker, images that are brighter. There are images that have some bubbles due to water or something similar. So this is a very complex problem, and we could not find a way to solve this with the standard algorithm or also machine learning algorithm. So we rely on the neural network to solve the problem with very good results. Here we have some tests that we did on production, but as you can see, here we were not able, with the computer vision standard, we were not able to get good results on this very difficult problem. By contrary, with the neural network, with I could not say little effort, because you need to check the images and verify that the images are well annotated and so on. But with little effort, we could solve a problem that was otherwise very, very complex. Another case study. This was a case study that we faced last year. Okay, in our production line, cartridge production line. This is the flange of the cartridge, basically. Also in this case, we used a classification neural network, and we were interested in find some defects on the flange. As you can see, okay, when the flange is good, okay, it's pretty fine. But when it's bad, there are sometimes very small defects, like the one in the middle, okay, that has a very tiny crack that is not that easy to be found using standard algorithm. Also, the third defects sometimes may be, it's not that difficult, but may give false rejection if there are some flare or some places where the light is uneven. Also, in this case, as I said, this was not a particularly difficult product, okay, because problem, sorry, because we already get some good results with computer vision, standard computer vision, but we managed to reduce the false rejection rate. And this was something that this was the aim, basically, of the project. Further, it was very important to be sure to remove the bad products as many bad products as possible, because the goal was to avoid to have extensive manual control at the end of the line. And so this is another kind of approach, or the same approach on a different problem. And in this case, as I said, we were interested in increasing the performances that were already quite good. Now, another case of study. This is something that we developed for Sanofi, and this actually was a feasibility study to introduce the AI on the line. But we are basically doing something very similar for the control of our syringes in the production line, in OMP production line. Here we applied an object detection neural network instead of a classifier, because we were interested in finding the defects within syringes filled with medical liquid. But the main goal was not only to find the defects. Actually, the real problem was that there are bubbles sometimes, because we need to spin the product to analyze it. And bubbles are the main reason for false rejection, basically. So we were interested in separating the real particles from the bubbles, so we can say, okay, if it is a bubble, it's the product is fine. If it is a real particles, the product is to be rejected. Here you can see some images, okay, of the some processed images, basically. So we feed the network with the images, and the network found these objects within the images and also classified them. So now you cannot see here, but in the first image, we have the bubble classified as bubble and the rubber on the line below. It's very interesting, this slide, because it shows you how the network can adapt itself and find the best parameters to solve the problem. Why? Normally, if we develop a standard algorithm, we will probably need to separate the two regions, the brighter region on top from the darker region on the bottom, that is the syringe plunger. Due to the fact that we have two different color, two different background, we will probably need to apply different threshold to the different to the two different areas. Further, if you look at the second image, the one with the green boxes, you will see that the glass particle that is represented here does not have a lot of contrast with the background. So it's clear that it's very different the condition from the first image, where we have rubber that is very dark, totally black, and the second image with the green boxes, where we have glass. And in the third image, also we have a white spot on the darker area, on the plunger area. And in this case, we should use a different threshold also. The neural network is able to do this just looking at the example. So we do not need to provide different threshold, different condition, different area. The neural network learn how to extract the defects both from dark area and from the light area. Both it is if it is very if the contrast is very high, like in the rubber case, or if the contrast is very low, like in the glass case. The final results here, we do not have a comparison between the two algorithms, because this was the intention of this feasibility was just to see how what would be the behavior of the neural network. But basically, we got some very good results, and in particular, the false rejection rate was pretty good, considering that we analyzed also images, syringes filled with bubbles. So we create artificially the bubbles, shaking the products just to see that the network was robust enough to avoid to take false reject. Okay, so these were some cases that we analyzed. As I said, we are applying the same techniques also to our production in OMPI. So we are moving on with several projects that are in which the final goal of which is to bring the artificial intelligence within our machine. And the added value that we aim to reach, of course, with the AI are, as stated in before, the reduction of the false waste that lead to a reduction in production times and cost, because we do not throw away products that are good. The improvement of the detection rate, because the final goal is anyway to find all the possible defects in the products that are going to the final customer. And the added value that we saw before of the artificial intelligence, of the neural network in particular, are that they are very robust to variation in incoming data, of course, provided that we train them well, okay, and can solve also very complex problems that are difficult to be formalized in a standard algorithms, as we saw for the anger clip, the bottom anger case. Okay, this is all on my side. Thank you for the attention. And if you have any question, I will be happy to try to answer. Okay, I will start to.
Thank you. Sorry, I'm sorry. Thank you, Federico, for this nice presentation.
Yes.
Yeah, so now is the time for the question. So you can ask the question in Q&R, sorry.
Yes.
At the bottom of your, so we have several questions. You can write your question in French or in English, but you prefer if you write in English, I can read it, and it's in French, I will translate it.
Okay,
so we have several questions.
Okay, well, if you want to translate them, maybe the translation will be better, yeah, but because, I understand.
Yeah. Do you use some transfer learning or that data augmentation in order to increase the number of defaults in your data training data set?
Yes, we use both transfer learning and data augmentation. Transfer learning is basically the possibility to use a pre-trained network. Okay, so we have some networks that are trained on data sets of mixed data set, basically, of our products. Wire cartridges and all this kind of products. We start from network train over images that belongs to our domain of expertise, and we just retrain, or let's say we fine-tune that network to improve the performances over a specific problem. We can sometimes we also start from scratch. Of course, it depends on the kind of problem and on the availability of a pre-trained network on our side. We use also data augmentation, of course. Data augmentation means to augment artificially, if we can say like this, the number of images. So the simplest way to augment the data is to take an image and flip it on the vertical or horizontal axis to change the resolution, the contrast, the light. So slightly modifying the image to make the network more robust. For instance, if you are not really interested in knowing if the defect is on the left or on the right, because it may be on left, right, top, bottom, we can flip the image or rotate it. So we give more data to the network. We use also some more complex data augmentation, and sometimes, when possible, we also try to generate artificial images, so artificial defects with the use of generative techniques. Okay.
Yes, thank you. The other question is more technical. Which tool did you use? Kera, TensorFlow, or another one?
Yes, basically we use Kera, TensorFlow, but we use also some other tools like PyTorch sometimes. It depends on what we are doing. But our main tool normally is TensorFlow. Yes. Okay.
Another question: in your opinion, Federico, traditional computer vision is definitively dead or not?
No, absolutely, absolutely not. And I explain you why. Honestly, at least for now. Okay, maybe in the future, I don't know. But for now, it is not that because basically artificial intelligence. The traditional algorithms are very good to solve a lot of problems. Okay, you can say that artificial intelligence, neural networks, are like a bazooka. Okay, you don't shoot with a bazooka to a small thing. Okay, and I'm speaking about bazooka because cannon, I don't know, because there is some work to do. So you need to collect images, you need to annotate the images, so apply a label or mark the defects within the image. So there is less work maybe for a computer vision engineer, but more work to do for a domain expert. Okay, so if a problem is easy to solve and can be solved easily with standard computer vision, there is no reason to use a neural network most of the time. Also, neural network are more demanding on the elaboration point of view. Yes, so you normally use them when it is needed. Okay, so if you have an increase in the false rejection rate, it's fine. But if you already have a system that is very good, probably there is no reason to move to the artificial intelligence.
Okay, thank you. I have one question. Your support is dedicated about a final product. You are linking with the quality services in your industry, in your groups? Because if you said is good and in fact is wrong, and what's happened?
Okay, that's a very nice question. Of course, we are very close with the quality departments when we do these kind of things. Actually, we cooperate with the customer normally because the end user, let's say, to get the annotation of the images. So we do not decide okay, if an image or a product is good or bad. We do this with the help of the quality department.
Absolutely. We have a protocol to qualify and to validate the machine. We have also a protocol how to treat the rejects when there is a default. So quality is highly involved because at the end, there is a decision if a product is good or not.
Yes. And also they are the one that validate the machine in the end. So
in the pharmaceutical industry, quality is very, very important. And by the way, in the cost of our product, the cost of quality and testing is most of the time the main cost of the product.
Yeah, of course. It's for this reason that I asked the question. Okay. So some other question? I can wait a few seconds if you would like to write a question.
also consider that we look at all the many kind of defects when we are inspecting pharma products. Okay, so we are looking at all the defects on the glass because you can have a crack, a scratch, the fill level may be not the right one, so some cosmetic defects. But we are also looking to the particles within the liquid. So yes, there are a lot of controls to be performed.
Okay. Thank you very much.
On nous entend, Ludovic?
Oui, c'est bon.
Oui. Bon, voilà, je pense que c'est cet intermède musical. Donc, merci infiniment à ces deux présentateurs pour les présentations réalisées, qui étaient vraiment de très, très bonne qualité, et véritablement dans le thème que nous voulions insuffler avec Ludovic. Donc, le webinaire est clos. Je vous rends la liberté, comme on dit, à tous les participants, et nous informerons prochainement des prochains webinaires qui devraient avoir lieu après le congrès de la SFGP à Toulouse, pour lesquels je vous invite tous à y participer. Il y aura d'autres sessions, justement, avec l'IA, avec le génie des procédés, et surtout un webinaire, un tutoriel, pardon, sur l'intelligence artificielle en lien avec les logiciels de flow checking type Aspen, Prosim et compagnie. Merci à tous.
Merci.
Merci.
Merci.